This is Mr. Brook, and we are going to start 17.1, which is about understanding polynomial expressions. The kind of key idea is looking at a polynomial. What is it? How do we simplify it? We are going to start with a lot of vocabulary in this section, so make sure you look back at the notes if you are stuck on a term. The key ideas will be used throughout this unit, so you need to be sure that you understand them. All right, our first vocabulary word is monomial. If you break it into key parts, mono means one, so this is one expression that consists of a number, a variable, or a product of numbers and variables. It means it's one thing altogether. So some examples: 4 is a monomial, x is a monomial, 4x squared is a monomial. Because these are multiplied together, it still counts as one chunk, one unit. Another example, 2xy. That would be another monomial. It's all together as one piece. Now, our next piece, when we're looking at polynomials, is the idea of a term. A term is just an expression that is separated by a plus sign. All right, so if we look, our terms in this section are 2x squared, 5x, and 7. There are 3 different pieces, 3 different terms. So 2x squared, 5x, and 7. Now, if we look at the second example, we have 3x. That is a term. We also have this minus 9x squared and a minus 8. One thing that we can do, since we have a term is separated by a plus sign, we can rewrite this. 3x. Now, subtracting is the same as adding a negative, so it's 3x plus negative 9x squared, and then plus a negative 8. So if we look at it, the terms are 3x, negative 9x squared, and negative 8. It is very important that you think about that term containing the negative piece. The negative is part of that term. All right. Next, we have a coefficient. Okay, our coefficient is going to be the number in front of a variable. All right, so in this case, our first one of coefficients are 2 and 5. 7 is not a coefficient. The reason it is not a coefficient is that it does not have a variable attached to it. If we look at our second example, the coefficients are 3 and negative 9. It is important that the negative stays with that coefficient. It is part of it. All right. Next, we have a polynomial. A polynomial is, it's more than one term added together. So if we look at 2 things added together, 3 things added together, 4 things added together, those are polynomials. It's more than one thing. All right. We have special names for 2 of these. A binomial, 2 terms. A trinomial then would have 3 terms. All right, so an example of a binomial would be 8xy squared minus 5x cubed, y cubed, z. There are 2 chunks that are added together. An example of a trinomial might look like we have 3 things that are added together or subtracted, because we can rewrite subtraction as adding a negative. All right, next. We have what's called the degree of polynomial. That's the sum of the exponents on the variable of the term with the highest total. So if we look at our first example, 8xy squared minus 5x to the third y to the third z. If we add up those exponents, remember x has a hidden exponent of 1. There's a 1 on that z. 1 plus 2 is 3, so this would be third degree. And this one, since it's 3 plus 3 plus 1, is 7. 7 is higher than 3, so this is 7th degree. All right. We'll look at this example. We'll do these two together, then you can look at the next couple year turns. All right, 7x squared. That has a degree of 2. This one has a degree of x to the third, y to the third. 3 plus 3 is 6. So it is a 6th degree. And it has 2 terms, so it is a binomial. All right, next one, 3 squared, 2n cubed plus 8n. The highest exponent is the 3, so this is 3rd degree. It has 3 pieces that are added together, so it is a trinomial. All right, I'm going to give you guys a little bit of time you can pause the video, try the next 2, and then when you unpause it, I will go over them. All right, this is a trinomial because it has 3 things added together. This 2 plus 2 is 4. 1 plus 2 is 3. And 1 plus 1, just adding the exponents, equals 2. The highest total is 4, so it is 4th degree. All right, and example 6, 2 terms, so it is a binomial. The exponents in the first one add up to 3, and in the second one they add up to 3, so this is 3rd degree. All right, our next key idea, we have to be able to write a polynomial in standard form. Standard form means that it is the terms in order from biggest to smallest. Now, what I mean by that, biggest to smallest exponent. All right, so an example, x to the third plus 2x squared plus x plus 3 is in standard form. X to the third is the biggest exponent, so it has to go in front. X squared goes second, the x to the first power goes third, and a number goes last. We also have what's called a leading coefficient. When you write something in standard form, the leading coefficient is the number in front of your first term. So if we have 6x to the fourth plus 3x squared minus 2x plus 9. All right, that is in standard form. The leading coefficient is the number in front of that term in the front. It is 6. Leading coefficient is 6. All right, if there was a negative, that would go with it. It is the number in front. All right, example 2. We're going to write the polynomial in standard form, give the leading coefficient. Okay, highest exponent is the third power, then second power, then just the x to the first power, then the number last. Remember, the negative goes with it, so negative 4x cubed minus 2x squared plus 20x plus 1. All right, example 2, the highest exponent is the sixth, the second highest is 3, and the last highest is 1, or the lowest is 1. So negative z to the sixth plus z to the third plus 4z. That would be in standard form. The leading coefficient, the number out front, is -1. And I think I forgot to write the leading coefficient up here. The leading coefficient is -4. All right, 7 and 8, I'm going to give you guys a minute to pause the video, try them, then unpause and you can check your answers. Okay, you can check your answers. They should go in decreasing exponent order, 5, 3, 2, and then the number by itself, the 10. It's okay that we don't have an x term in there. That wasn't part of our polynomial. The leading coefficient, since it's just x to the fifth, it's that hidden 1 in front. All right, and for number 8, they go in descending order, 8th power, 5th power, 1st power. Make sure the negative goes with your term, and the leading coefficient is what's in front. It's -3. All right, and our last little piece for today. We're going to look at simplifying polynomials by combining like terms. Like terms are the same variable to the same power. Unlike terms have a different power. So what I want you to do when you're doing this is to kind of look at these and determine what are the same powers. We have a y to the third and we have a y to the third. Those will go together. We have a y squared and a y squared. Those will go together. All right, so -2y to the third plus 2y to the third. These two things cancel out to make 0. These two things, -8y squared plus y squared, makes -7y squared. So that will simplify down to that. And one more example. This one's a little more complex, but if we look at it, we have p squared q3. And we look for any others that are p squared q3. They have to have the same variables to the same exponent. So those two will go together. We also have a P5Q4 and a P5Q4. So those two things will go together. Combine them. -4 plus 3 makes that -1 P5Q4. And combining these two, 1 minus 4 makes -3 P2Q3. All right, so that's combining it and simplifying it that way.